let's go to our studio. You're already in our studio. Tools, install packages. And again, it says, so it has a couple things. So install from, almost always you're going to say repository is cran. Sometimes if you have downloaded a package on your computer, you can install from there. But most likely, almost 99.9% of the time, you're going to be installing from cran. So here we want the read XL package. Okay? Do you want to install dependencies? Yes. Keep everything else as the default. Click install. I've already, if you already have it installed, you don't have to do this. So you see the code that it generated over here. Install that package. That is the function that you can use to install packages. So now, if you've done that, you should be able to say library read XL, and everything should work just fine. Or I mean everything, you should see no more red. Now, I'm going to restart my R session really quickly. So we want to read this data set. So again, before maybe looking at the code, again, I would highly suggest if you're going to try to import a data set, try to use the RStudio Sorry, this is too zoomed in. So if you go to File, Import Dataset, now we go to Excel. You can paste the URL there and click Update. So this should work for almost everybody. This used to break sometimes on some Windows machines, so I want to see if some people can try it out and get some nods on the Windows side. Yes, you see something? Great.
Is it an import base data or text data?
So it should be import Excel. So if you have this package installed, that should be in your RStudio. If it didn't come up when you click the drop down, you might have to just restart RStudio. So the link is in the data lab, data IO lab on the website. Huh? Why don't you? Yeah. So on the website, if you go to data IO, it should be lab from yesterday. Does everybody? Most everybody has it. All right, so I'm gonna go back to this. You click update, it'll show you. So it shows the first 50 entries. Things look pretty okay. It installs things. So the one thing I will say, by default, right, it will try to name the data set to usually something of the file name. So it's monument.xlsx. It'll try to name the thing monuments with a capital M. I would suggest probably most times changing that out of everything. Obviously change these options if something doesn't look right up here, or something didn't seem like it actually read incorrectly. But like I usually have variable names to be a lot shorter, but still maybe a little bit more descriptive. So not just X, so mon, I'm going to probably remember that's the monuments data set. So we can update that. Say mon, and say import. So now I can zoom back in. So now we actually see this data set in the data viewer. It gives us a little viewer. And again, if you click up over here, yeah.
I'm getting that error message.
Andrew, you want to? Okay. So if you didn't get that error message, this should be the code that pops up, or something very, very similar. Right? So if you click up, now you can copy and paste this thing in there. Now, if like you were doing an analysis, at the end of the day, you have the ability to just run that command. Now, I will say a couple steps on what this does. So in the actual lab, we ask you to download an Excel version of this. So we ask you to download it to your hard drive. When you do that importing process, all that fun stuff, you'll see a couple things. This is the URL, this destination file, dest file, and this function that actually downloads the file to your machine. So just a heads up, every time you run this, it's going to try to download the file over and over and over again. So, although the drop-down menus are really good, and they do exactly what you want, it downloads it to your machine, that's great, that's what you want it to do, but it's not always great because you don't want to maybe download that over and over and over again. So, that's why we said in the lecture just to download it to your machine. And also, if I look into the files pane, right, you should now see a mon.xlsx. So because I didn't tell it anything else other than the file name, this is where I wanted to download. By default, it downloads within the directory R is looking at, which again, if you look up here, is desktop R class. Okay? Does that make sense? So we said it said download it, it's on the hard drive, and it'll download things, or in the future, for example, read things looking at whatever directory you're in. Okay, now that that's already been downloaded, you can take out most of this because now I don't need to download it every time. Okay? Does that make sense? I took out the code that downloaded it because I downloaded it once, it's on my machine, I don't need to do that again. If you deleted it, you have to download it again. Okay. So, does that make sense? So again, most times, you're going to have an Excel file on your machine already. You don't have to go through this import process. It's not going to try to download it. So like for example, if we already had this downloaded and we went to the importer, import dataset from Excel, and I say browse, and I say mon.xlsx. Sorry. When I zoom in, it's like very, very small. So if I go and I now select it from my hard drive, from my machine, it says, okay, run it, or I'm going to import it, and you see the code over here. I can just run it again. It's not going to do any of that downloading. So most times what you're really doing, what you're going to be doing in most practice, you'll have the data already on your machine. You're not going to be downloading it from anywhere, or you're going to download it one time. And this is the type of code that you'll be using. But again, it will, if you do have like a link to an Excel file, the code will pop up to show you how to download it automatically and get it on your machine. That is not super useful for data sets that like never change, but if, for example, whenever you run that report, you want to download that data set and that data set updates, for example, it might be a useful tool in the future. Okay? So far, I've pretty much said, like, R doesn't have drop-down tools for everything, except we showed you drop-down tools for everything. That will change today. Okay. Now, we have mon in our hard drive, and we want to write it out as a CSV. So again, what's the function to write a CSV? Write _CSV. Now, this is what I was talking about before with tab completion. If I say write, you'll see what comes up. So this is write.csv. It's not the one we want to use. So I'm going to say write _CSV. And I'm going to say mon, and I'm going to say mon.csv, for example. I'm going to get an error. So this is a very important distinction. So when we install a package, that downloads it from the internet and puts it on our machine, puts it on your hard drive. But because we said there's like 15,000 packages that are accessible to R that you could download. So every time you boot up R, you don't want all of them to load up. You don't want the functionality of all of them at the same time because some of them conflict. Like some of them do something over here that might not jive with something over here, right? A lot of different people made these things. So, although we've installed the readr package, right? Andrew talked about the readr package for reading and writing CSVs and tables and all that fun stuff. We have it installed on our machine. But until we write library readr, none of those functions are accessible in this session. Okay? And if I close RStudio, close it down and open it back up, next time, if I want to use write _CSV, read _CSV, whatever, then I have to use library. Again, we could have tried the, so it's just for, okay, they have an import button, but not an export button. Kind of interesting. So now that we have library readr in there, let's put it in our code. If I say write_CSV, nothing shows up. We look in the files, and we see down at the bottom, mon.csv.
What's the difference between .csv and underscore?
A world of difference. So they have vastly different defaults, so they don't do the same things. For the most part, writing out is very similar between the two-ish, but reading is drastically different for all the reasons Andrew said yesterday. So for example, like it'll assume, let's say you have a column of words or cities and stuff like that. By default, read.csv will read that data in and think you want to convert it into this like categorical variable, which is not the worst idea if your data is clean, right? If the cities don't have spaces here and dashes here where they shouldn't, right? Almost every data set I have ever imported into R is not clean. So I have to do some manipulation to that before I want to turn it into a categorical variable. Read_CSV doesn't do that by default. It says, hey, you probably want to keep that as just words, you can manipulate it, and then if you want to turn it into a categorical variable, then you can do that on your own later. So it's also faster, there's a lot of other set of perks, but two things I wanted to demonstrate. Let's go back. Right, now that I have this package loaded up, now that I have it running, if I say write underscore, before, it never showed me this option. So you see, so all I did was hit write underscore, hit tab, then these things came up. So this is what I'm referring to as tab completion. This is what I'm talking about where RStudio make things a bit easier. So it gives you a lot of different things. One, write_CSV, if I hit tab, it'll complete that word. So I don't have to remember every single function name if it's got weird uppercase or lowercase, whatever. Then it tells me what package it's in. It's in the readr package. And then lastly, it gives me just a snapshot of what are the arguments that you put in. What do you put into this function? So first argument is just x. Second argument is path. Other options that you can put in there. So if I hit tab, now also RStudio says, hey, nobody remembers like what the argument names are. So just in case you need to know, here they are again. So here, when you're actually using functions, right, before, so now this is a different type of tab completion. So it showed you before, when I'm actually inside the parentheses and hit tab again, it then shows me these are the arguments for this function. So again, starting out, it's like, how do you remember, like, it's like, you put the data set first and then the path and like, what's the last, I don't remember all that. This tab completion thing can help you remember things like that. So, if you don't set an argument, right? So this is setting mon equal to x. This data set is equal to x. This is an argument. X is an argument within this function, okay? So x is not out here. It's not something in your environment. It's saying when you pass things into this function, you can either just put them in order, like as we saw before. It's x, then path, then a whole bunch of other stuff. Okay? So you can either put them in order. So if you put them in order, R says, okay, you put the first thing in, this is x. Second thing in, that's the path. Or, what is much more robust, which allows you to put them in any order you want, you actually name them. You say, this one's the x. Right? So if I run this, it still works. But the big difference is this works. So this says x, the data set I'm putting in is this, right? Then, after it says, okay, I took the first argument, I know which one it is, then it goes in order again. So the second argument is path. It's not specified. So it says, hey, you got an argument here, doesn't have a name on it. I'm going to assume that's the second argument in path. This still works. This works, But this does not. It doesn't work the way you think it would. Because again, if you don't name them, if you don't say this is the X argument, this is the path argument, and so forth, then it just goes in order. So it says this is your data set, this is the path to the hard drive that you're using, and that's not what we want. So again, many times when you're starting out and you don't know the order of the arguments, use tab completion to figure that out. And then also, to make things more universal where you can put them in any order, if you don't know the order by heart, which takes a lot of time to kind of get used to, you can just use the argument names themselves, and the way it is argument equals whatever you're putting into that argument. Now, this is very important. You can't use the assignment operator here. Inside a function, it's equals only. Okay? You cannot do this. That is not what I'm saying. This is assigning a variable to the R environment. That's not what we're doing here. We're saying for this function, we're passing this thing in. We're saying whatever the code you have to run to write out a CSV, and you need to know what the path is, set it to that. Is that clear? So again, R by default will go in the order of the arguments in which it's in, where you don't have to specify them, but it's a lot more robust, it's a lot more explicit if you actually name the arguments. But nobody remembers all the names of these arguments, right? For example, like it has a bunch of them. So using tab completion within the parentheses, within the function, allows you to access that list of arguments where you can just say, oh, I want to say append equals true. Right? Stuff like that. All right. So data import right now, still totally fine to use the drop-down menus. It'll give you the code, but when you actually run the code, that's all you need to do. You don't need to click anymore. Once the data, you have the code for importing one time. And then writing data out, usually write underscore. If you have the readr package loaded, there's a whole bunch of write underscore functions, which usually have almost all the need you would ever have. So CSV, CSV2, delim, Excel CSV, write file, write lines, write an RDS, write a tab separated value, things like that. And then all the other things. So whatever type of format you want. And again, Andrew touched on this yesterday, the Haven package. If you wanted to say write like SAS, right? Write a DTA for Stata. Whatever version, so these are the arguments you can put in there, the data, the path, what version of Stata is it accessible? Do you want to label? Is there a label for the data set, for example? Stuff like that. Okay? So readr harmonizes almost all the types of reading you need to be for text-based stuff. Haven has all the accessibility for reading in foreign formats and writing those out. And then read Excel is a third package that allows you to explicitly read in Excel files. So I understand that you're like, well, I need 3 different packages to like read data in. Most of the time, I would say over 90% of the time, I usually am using CSV, right, in general. Maybe the other 5 to 7% is a Excel file, and the rest are probably these. So that might be different in your day-to-day work, but Excel still runs the data collection world. So, all right, any questions on the lab before we go move forward? All right. All right. Now, we're going to teach a whole bunch of...
How come the file size changed?
From CSV to Excel?
Yeah.
Oh, that's a... So Excel is technically like... in the background, even though you like click it, it opens up just a spreadsheet. It's like a whole zip file with a whole bunch of different attributes and things like that in the background. So it's just the different file formats. It can be compressed and things like that, where CSV is just like literally just a text file where they dump in words or numbers with commas separated. You can zip them up and read. You can zip up the CSVs and read them in R back and forth. So you can compress them if data size on your hard drive is a concern. All right, subsetting data in R. I'm going to be talking about a lot of what they refer to as verbs today. So if a tibble or a data frame, pretty much a data set is a noun, these are all the verbs. These are mostly all the verbs you need to know. Okay? We're going to be talking about renaming columns, subsetting rows, subsetting columns, adding or removing new columns, or manipulating them in some way, ordering the columns of a data set, right? So I want to sort by this. Ordering the rows. So I want to move the columns around, I want to move the rows around, and then I want to subset the data based on like the 5th row or some condition. The condition being like age is greater than 5 or something like that. So, this is the package we're going to use, dplyr. There's a lot of really, really clear and good resources online. I'll try to be as clear as humanly possible, but sometimes other people, it jives with other people in different ways. So there are some really great tutorials in here that I will say are relatively short. Right? They're not like 50 pages of like how to do everything in here. So DataCamp has a module on it. These two pages have a lot of great resources on there on how to do everything in dplyr. So dplyr gives you all the verbs you need to work with data sets, more or less. So, again, Andrew touched on the tidyverse, right? Tidyverse is like 8 packages, but they do, like, if you're starting out, like 90% of what you want to do for most standard data operations, right? Certain plotting functions, you want to work with strings, you want to do data manipulation, which we're going to talk about here. You want to work with dates effectively. It's got that loaded up. Now, this is what I'll say. Starting out in R, it is a good idea, in my opinion, to start every single R script, every single R Markdown document with this line, library tidyverse. Because it'll have, so like I said before, you try to write CSV, and like read R wasn't loaded, like those can just cause immense frustration starting out, right? It's like, oh, I forgot to load this page. It's just like, pretty much it leads you to trying to just throw your laptop off the roof, right? So, putting this first makes it pretty, not foolproof, but it's usually a pretty good idea because like ggplot2, the main thing we're going to talk about for visualizations loaded up, Tibble, right, so creating data frames and stuff like that, tidyr, which we're talking about for reshaping data, for pivoting things wide or long, or making rows into columns or columns into rows. I don't know why I said ggplot2. readr, the thing we just talked about. These other two, we'll talk about stringr for working with words and strings and string manipulations and stuff like that. And forcats, which will allow us to work with factors, which are the categorical variables in R. And again, forcats, it's just a reshuffling of the words for factors. And if you are a cat person, there's like R cat ladies. There are groups of R and cat people. I'm more of a dog person. So, also, when you load this up, it'll just give you this list of conflicts. You don't necessarily have to worry about them right now. The idea is simple. Like I said, there's 15,000 packages, right? Nobody's that unique where they make their function names different than everybody else, right? A lot of people use plot. A lot of people use reshape, or like words that kind of everybody would be like, oh yeah, I would use that. Sometimes, so if person A made a package, person B made a package, and you loaded person A and person B's, R's like, I don't know which function you want me to use, right? You made a function called A, you made a function called A, should I use yours or yours first? In R, it uses whichever one was loaded last, by default, okay? So if you, for example, so this is what it's saying. It's saying dplyr filter, the filter function from the dplyr package, is loaded up. What it does is it masks this function from stats filter. So, by default, when you load up R, the stats package is loaded. Every single R installation, stats package exists, right? So when you load this up, we load up dplyr. Now, if you're like, oh, I really love the stats filter function, or again, whatever function you have in whatever package. If if you actually want to use that one versus dplyr, most of the time for all the stuff we're going to be doing, you're not going to want to use that filter function. But if you did want to do it, if you ever saw this masking thing, then you would use the package name, colon, the function name. So the nice thing about tidyverse, you don't have to remember, is filter in this package, is read underscore CSV in this package. I don't remember any of that stuff. Tidyverse loads it all up. But if you start loading additional packages, right, that aren't just the tidyverse, you might accidentally load up a package that has a function that conflicts with one of these, and your code might not work the way you think it will. So this is a very kind of technical point, but all I'm saying is that's what this conflict means. That's what it's saying, is that there are two functions accessible to you called filter. There's this one and this one. Whatever one masks the other one, if you just say filter, it's going to use that one. So whenever we say filter from here on out, filter, we mean that one. If we ever say lag all over the place, we mean this one. Okay? That's all that's saying. But when some people do load up packages, when they say library dplyr, for example, they do get, they're just messages telling you of this. And they think like they're errors or warnings, and that's not the case. All right, so again, this just reiterates the point. If you just write, so load up, say library tidyverse on your machine, and then write the word filter. And this is something that should come out. So pretty much it'll give you this non-descriptive function, but the whole thing I want to show is right here. So if you say filter, it'll say namespace dplyr. You don't have to worry about that. It's just saying if you use this function, so you're like, which one is loaded up? I can't even remember right now. You say, if you just write the function on your console, it'll tell you which package by default it'll grab. Okay, we don't need any of that stuff. Okay. So, now that everybody has the JHUR package loaded up. So now, downloaded. So if we want to use that package, we just say JHUR, right, in our machine. And then again, we said there were a lot of data sets already loaded up in that package. JHU cars, for example. This is a very simple data set where it has, again, information about a car, right? Which car is it? What is the miles per gallon, cylinders, displacement, horsepower, other things like that. Okay. So, again, we're going to be using this data set in some of the examples here. All I'm doing is I'm creating a new variable that's a literal copy of this one called df. So for a lot of my stuff, I use df. A lot of people use dat, right? DAT for a data set. So that's not uncommon. So every time I'm going to be doing anything with like these verbs, right? Subsetting, manipulating, I'll most likely be using df. So I say df for data frame or ds for data set, whatever tickles your fancy for that one. But again, this is the data set. Also, anything I do to df, anything, I could delete it, I could remove it, I could change all the columns, change all the names, right? It's not going to do anything to JHU cars. Remember, this copying they're not bound together in any way. So again, I want to just show you, we did say Tibbles and data frames are a little bit different. This is the main difference. So TBL is a Tibble. So the way we convert a data frame to a Tibble is as_Tibble, right? Again, this doesn't matter if you've read the data in with read_CSV, whatever. I'm just saying if you accidentally have used like read.csv or something like that, sometimes it's an easy gut check to see because the way a Tibble is displayed is a little bit different. So one, it tells you it's a Tibble, right? If you print it out, it says it's a Tibble, and then what it shows you is every single column and what kind of data type it is. So for example, cars is a character, miles per gallon is a double or a numeric, it's a number, cylinder's a double, they're all numbers, they're all numbers, they're all numbers, they're all numbers, right? That's what DBL means. Before, when you just have a data frame, it doesn't show you anything. Also, like I told you before, if something has a million rows and you print it out, if you just say df and had a million rows, it's going to try to print a million rows up until like 1,000. Tibbles are smarter. It's like, you don't want to do that. I'm going to print out like 10. So again, this is a slight distinction. Almost everything you're going to be using, the readr package, the read Excel package, and stuff like that, is going to give you a Tibble. So I'm just saying this is what we're going to be seeing for most all of our data sets that you're going to be going forward. If for some reason you don't see those things, it just happens to be a data frame in this code. It's not a big deal. Let's get this out. Okay. Let's rename some columns. So again, especially if you're reading data in from Excel, the column names are going to be usually pretty heinous. So we have this data frame that we had, df. Now we say dplyr. So I'm just again showing you this from the dplyr package. You don't have to know this. You can just use rename. It doesn't matter. You just say rename. What is the data set you're putting in for all the verbs we're talking about? First argument is the data set. First argument always is the data set. So you say rename, this is the function, this is the verb, I'm renaming, what is the data set, and then what are you doing? So in this case, when you say rename, new equals old. So the new name that you want to be in this data set, you set it equal to whatever the old name was. Yeah.
So in the Learn R homework,
Mhm.
they mentioned to do piping instead of
We will get to piping.
First argument or whatever.
So we'll get to piping in a little bit. So we're going to talk about the verbs first, and then we're going to shift over to piping them. So for those, as a preview, piping, many times you don't want to just do one thing to a data set. It's like, oh, I want to rename it. It's like, oh, I want to subset only these columns, and then I want to rename this column, and then I want to change that column to this column squared or whatever, right? So to do that operation, we're going to chain them together one step at a time in a clear way. And we'll introduce this thing called the pipe to make it much more readable. Okay, so new equals old. Okay, set the data set, so rename, new equals old. Now, again, by default, when you just do something in R, all it thinks to do is like you want to print it out. If you want it to stick, you have to reassign it. So we're saying, this is the data set. We want to rename df to lowercase mpg to uppercase mpg, and we want that to replace the old data set. Okay? So just saying this thing on the right-hand side, rename df mpg equals mpg, if you just did that without the reassignment, without df equals, it's going to print it out. It's going to show you that this column has been renamed, but it's not going to do anything. Like when you start working with df again, it's going to not have changed because you didn't reassign it. Okay? Here, I'm just resetting it back for the next couple slides. So, there are, yeah. So I'm just saying df is now something new, right? So df equals the output of this. So the output of all these verbs is a data set. Is a data frame or a Tibble. So what I'm saying is rename data set, new equals old. The output of that is a data set with the new column renamed. Now, if I just ran this, if I didn't have any of this there, if I didn't have this here, all it's going to do is print it out.
So this way it's reassigned already.
Yeah, so so it's assigned, right? I'm assigning df to this. And whenever I say reassign, I'm just saying df already existed. I'm just updating it or changing it. So that's what I mean by reassigning. So I'm just overwriting it. So almost all the functions I'm going to talk about today, all the verbs, have a couple different variants, right? So rename, what you can do is mpg equals, so before we could say uppercase mpg equals lowercase mpg. If we wanted to name a bunch of different columns, we would just put a comma here and then say, what do we want to rename this? Let's call it just, ratio equals drat, something like that. So just comma and then go on, so on and so forth, with however many columns you want it to, rename. Now, sometimes you don't want to do that. It takes a long time. You have to remember, so you can do tab completion and all these fun things, but it takes time. It's like, I just want to rename all of them. So almost all the variants I'm talking about today, about manipulating columns, adding new columns, things like that, there's going to be a variant that's that function name, that verb, underscore all. So for example, rename is the verb, rename all is also a function. So this is more of a shotgun approach, but it's very different syntax. So before, I said, hey, this is my data set. I want to say new equals old, new equals old, new equals old over and over and over again. I could do that. That's a very explicit way to rename all the columns of your data set. Let's say I don't want to do that. I want to use the rename all function, which again, first argument's the data set every single time. But then, for this command, you don't just say new equals old, new equals old, new equals old. You give it a function. What do you want to do to these column names? So toUpper is a new function we're introducing. Changes everything to uppercase. So what I'm saying here is rename all the data set, rename all the columns in this data set to uppercase, and then I'm gonna create a copy of this data set, dfUpper, that has every single column. It's the exact same data, but now all the column names are changed. Okay? Shouldn't be mind blowing, shouldn't be earth shattering yet. Right? We just rename stuff. Okay?
If you want to rename, say, it's 2 columns, would there be a comma or other letter in between the name?
So it would be a comma between these two. So for example, say let's say something like that. If we looked at that and we look at that column, it's no longer drat, it's ratio. Okay? A lot of times I will say, I have found students like do something where they run this again. Well, you can't rename the column now, because remember, it's new equals old. Right? This column doesn't exist anymore, lowercase mpg. We already renamed it. So since we reassigned it, the columns are different. Right? So what I'm saying is, once you've reassigned it, you have to remember it's always new equals old, and if old doesn't exist, for example, it's going to give you an error. Right? So we'd have to reset that data set and then say like, what else do they have in there? HP equals HP. So now HP, drat, and MPG are all renamed. But again, if we try this command over again, because we've already reassigned it, these columns no longer exist because we've already renamed it. Okay, so let's go to lab part 1 on the website. So if we just go to the website, we're going to subsetting data, and we're going to the lab, and then we'll be floating around. So you should be able to download that, the lab, and then just open it up in RStudio. And then we have a couple things. Remember, so we have these functions, these library functions already in there. So when you start any lab, kind of from here on out, because we're going to be using these tidyverse things, I would suggest the first line, you just click this button. So it's a little down arrow with a blue line, or green line, which says run all the code chunks up until that point. So it's going to load up whatever packages you need. If you need a certain data set loaded, unless the point of that exercise is to load the data set, it'll have it already in there. All right. So take about 15 minutes and regroup around 9:35. Hey, did you put that link on the website for the YouTube?
No. Yeah, it wasn't uploading last time, so it should be now.
I mean, I can put it in there. I just. Just see.
So much.
How do you respond? Yes. Okay.
So
So right now, just to see if you have it, just see. So right now, it's just right empty cars. Yeah. So you have it. So yeah. So this is just a preloaded file. This is preloaded data. Sorry. Yeah. So for the first one, this is empty cars is a preloaded data set in R. You should just be able to just write, see if empty cars, if you write it in the console or write like head empty cars, just to make sure it's accessible. So like head empty cars, this should work. If this doesn't work for you, then something's probably going terribly wrong. You could also use the JHU cars one, which is a little bit different, but you might get a little bit different answers for like the class of it, for example. Oh, the code. So yeah, but like that's basically, but so that was day one, right? Have everything. So would you say, for example, insert R.
yeah, so
Yeah. But if you just have, so this first one, don't worry. You should have the answers. Just that's if it's one, you have the answers. Yeah. So sorry, that's today. Yeah, sorry about that. Yeah.
Sorry, how do we find how many observations?
So right now we haven't given me the code to do that, so just do it by eyeball. So either use str for like what we talked about yesterday for the structure. You could also look in your environment. If you say like cars equals empty cars. We showed it, but we didn't really talk explicitly that that's what that does. So right now, before we're getting into some of these, it's just eyeballing some of them or looking at them. So again, 32 rows or 11 variables, things like that. So homework 1, yeah, it's filter on it. Or 2, homework 2, which we sent yesterday. Let's do Thursday, right? Yeah, but people start doing it.
They finished up. Trying to get them.
I mean, I'm just sad from fooling around.
We just do Thursday, right?
Yeah,
That's it.
on Java.
For all. Can we jump 10 years?
Can you Pin comes with full.
I know.
When?
Can you check the course message and see why I'm getting emails every day? It's stupid. Are you guys getting emails from Course Plus? Yeah, that's just like session 2 is today or something. Okay.
Yeah,
I'll
I
try
think
that.
that's.
I'll fix that.
Is that
No,
normal?
We don't know that.
That's probably why we don't use it that much.
It's the price of pay job for the Dropbox.
One email a day. She says you class.
But they're not set up right. I feel like they set them up automatically or something. Let's see if I can figure it out.
Homework 2 and the other homework, so you be short.
Yeah, they're more like doing analysis and stuff.
Okay.
You only have to do the 3 parts though that they put academy. You don't do the whole thing put academy. It was just the 3 like 12.
Pay for it?
No. It was like 10 modules.
Oh, yeah, that's it. Okay. So you
Yeah.
do the whole thing, but not the pro version.
Yeah.
That's what. Yeah, that's what.
Yes.
Yeah.
Yeah, it's not due for another day or so. Like, you have a little bit more time.
No,
You do
part
that
2
tomorrow.
is after.
No.
I mean, if you want to look ahead,
It just helps you sort of get like. Okay. We used to send it earlier, but like it was a good filter sometimes. People started like, I can't do this. Yeah, it would help. Just so again, it usually helps filter people like if they've never seen R and then they start doing that. Like, this is not for me. I'm out. You only have that first day to drop it. Yeah. And that's happened in the past. People are like, I started that. I was like, that was me. Or like, I've never done it before. It's crazy. Yeah. So then it's usually a good barometer.
Future, if you say like, if you car loading, you don't sometimes say cars or something else. Hold on. You have to rerun the whole thing. So what if you so R will let you overwrite game, right? Including game sense. But the reason you wonderful at that is because many times you manipulate, you are making changes. Because sometimes you might want to collapse, like let's say for example, you have 3 patient records. You want to condense it just to 1 or an average or something like that. So, and you don't want to usually create like 5 or 6 copies of your data set. So you're going to just overwrite. Like you use DS over and over again, maybe, or like that or something like that, or like my data, something like that. Because otherwise, my data 1, my data 2, which is very hard to keep track of. They're unbound, so it's very hard.
About renaming all.
Yeah.
About renaming all of the variables. So, what we're doing is just making them uppercase, but if you wanted to like completely change them and you had a list of should be in the same order, could you like then skip that list?
Yeah.
I'm just wondering if there
How
are
would you do that? You call it. You just call it.
We're not teaching that.
Sorry. So you can do it, but not with this.
So it's possible.
I'm just wondering.
It's like base art. I do
But
it.
it's probably like 5 or 600.
Once. You don't even back to it.
Right. This is the argument you have with base argument. So it depends on what you need. So you have like a mapping or something like that.
Yeah, right.
It's possible.
Like if you had a cost one. I'm just thinking of this as a problem.
There are ways. Andrew's right though. It's probably easier in the base array, which I'll talk about with colonies are, but like it allows you to manipulate colonies like they're just like straight vectors. So you just essentially grab the column names, merge or map them, right, and then just put the columns back. Whereas that's not super straightforward.
Yeah. The magic part. If you just want to manually just give it a whole new vector column,
Yeah.
that's easy.
Yeah, that's easy.
So the magic part. Yeah. That's.
Yeah. So usually like I said, you got like old or new name, old name, and I would just like in text editor copy this huge command. But Andrew's right, there are some
I thought you didn't mean the magic part. I thought you just meant how do you just overwrite the whole vector.
Well, I mean, I guess like if they happen to be in the right order already.
Yeah, you just.
And then there's a function called column names that you can, which will grab the column name, but you can also assign it. It's just a. I'll show you that, but it looks. I'll just also show you why that looks very confusing.
Yeah. So you don't have to show it. It's gonna be.
Well, I mean, we're gonna bring it up. At some point. Did you say?
I think part 2 is right.
No, not part 2 yet. Stop on part 1.
Yeah, today's more intermixed between like one part of the lab, one part of the lecture,
Yeah.
one part of the lab, one part of the lecture.
Alright, who's ready to move on to part 2? Or at least the lecture? A little bit. Some people. Okay. We got like, maybe. I don't see a hand. I don't see a hand, I don't see typing, so I don't know.
Ask who's not done.
Yeah.
Maybe they're too engrossed to raise their hand.
That's right, they're too involved.
Got my new Southwest business card.
Look at
Like
you.
a pen cast. Get that pen cast.
Everything's being recorded, so.
Oh, yeah?
You keep,
Oh,
you
really?
keep, you keep talking in front of that computer.
Forget that it's always on the photo.
YouTube will talk about it. Okay. Alright, let's go over some of these really briefly. So let's see if you have the MT cars data set. I said this kind of broadly. So MT cars is like a special data set. It's preloaded with R. So also the JHU R package has some data sets already loaded. So we want to just, like the purpose of this isn't to do like, reading data in, any of that kind of stuff. So we just wanted to use a data set that was already loaded in there. So if you say MT cars, you should be able to see it. You could do head MT cars just to see the top of it. You could have done view MT cars. Anything, just be like, okay, when I try to run empty cars, like, I'll have it. Now, I will say something. Some of these preloaded, these data sets that are inside packages and all that kind of stuff, although you're manipulating them, you don't actually see them in your environment because they're kind of like behind the scenes. That's why in the next, down here, we say cars equals empty cars, so that you actually can see it in your environment and see how things change. So what is the class of empty cars? Data frame. So the class, again, returns the class of an object. If it's a vector, it'll tell you if it's a numeric, a character, or whatever. If it's a data frame, it will say it's data.frame. How many observations and how many rows? There are a lot of different ways you can do this. So if I say str empty cars for the structure, it'll tell me a data frame with 32 observations and 11 variables. So for data frames, they are two-dimensional. Before we talked about length, right? Length of a vector. How long is it? Data frame is not the same thing. Length is not the command you want to use. The three commands I'll talk about today, a little bit later. So dim empty cars gives you the dimensions. nrow empty cars, ncol empty cars. So dim gives you the rows and the columns together in a vector of length 2. nrow gives us the number of rows. ncol gives us the number of columns. So these don't work on vectors. Like let's say x equals 1, 5, 6. nrow x. Oh, that's not a function. nrow y or ncol x comes up with this thing called null. It's pretty much saying like that doesn't exist. This doesn't make any sense. Those don't have rows and columns. They are just one dimension. Data frames, Tibbles, nrow, ncol will give you the number of rows, the number of columns, and then dim will give you both of them at the same time. But I would say more frequently you want one individually. Yes?
The data in the global environment, the empty cards shows that it has 32 observations of 11 variables. Is that always, that's not always going to be the case, right? Because you can pretty much figure that out that it's 11 columns.
By look in the environment.
In the environment.
Yes. So yeah, exactly. So so if you're working interactively, you want to say how many rows we got, you can spot check it here. But if you want to extract that or do that programmatically, either for reporting or actually doing something or doing some checks in there, or just saying like I don't want to jump over to the environment every time, you can use nrow ncol. But yeah, you can right now Totally fine for your homework, stuff like that. Just say, I saw that there were 20 variables in this thing, or I saw there were 16 rows or something like that. And again, if we just say empty cars, we could have counted the columns, things like that, but we're programming now. We're not going to be doing that. We're not going to be counting things necessarily up. So we're going to copy the empty cars object into an object called cars and rename MPG in cars to uppercase MPG. Use the rename function. So here, I'm going to say rename cars big MPG equals lowercase MPG. Right? Now, if we look, we see big MPG. Now, if I just say head cars, MPG, again, still hasn't changed because what I didn't do is reassign it. Okay? So if I want this renaming to stick, gotta overwrite the object. Alright? So let's convert the column names of cars to all uppercase. Yeah.
Don't we need to add the dply r double colon?
You don't.
Oh, wait, no.
You don't. That was so that was just showing you in many respects that it was coming from the dplyr package. So again, if you load up tidyverse, it's already loaded.
So I just use the command.
Yep, use that command. But this, I will say, this becomes a growing problem when probably about a month and a half from now, if you're still using R. Because you'll be like, oh, I have this other package, I want to do something. I'm loading the tidyverse every time, then I'm loading this other package, this other package, this other package. And then, inevitably, you'll hit some package that, for some reason, has a function called rename, or something like that. Right? So that's why I talked about all those rename things and the masking and that kind of stuff. If you do run into that, either you got to reorder the way you load things up, so the order of the library commands matters, or if you're like, I only want to use one dplyr function or something like that, or in most cases the opposite, you're like, I have this special package that does exactly what I want the way I want it to, I want to use that rename, and then it'll be like, best package, : if you wanted to use that in your code, but have dplyr as the default for everything else. Okay? All right. Now, convert the column names of cars to all uppercase. Use rename all and the two upper commands. So again, I want to make things stick, so I'm going to say cars equals. Say rename. Now again, you see all these different options. There's rename at, rename if, all these kind of stuff. Rename all. And then it says, so I will say, these functions are great. The documentation, a little bit not intuitive. Let's just put it that way. So if you hit tab, these are the arguments of this, which is a little bit confusing. Again, you always have to remember the first thing is a data set. So that's what it's saying here with Tibble, a Tibble object. Just put in your data set, and then .funds is a function. So again, not very intuitive. A function fun, a per style lambda tilde fun dot, or a list of either form. Super confusing. So again, I will say a few things. We will talk about how to get the help today. Vignettes are like long form documentation that show you how to use stuff. Right? One of those links in the slides where I said like they're really good resources. This package dplyr explicitly has amazing functions, great vignettes that show you how to use things. The help files couldn't confuse you more if they tried, in my opinion. So like if I look at the help file for rename all, just so I'm like, what do you actually put in here? So it's like, what is the description, the scope variance of like what? And then there's all these other things that, again, if you're trying to use these specific functions, the Google is more your friend than the help files in this instance. That's all I'm trying to tell you. So again, rename all or any of the functions underscore all. The first argument's a data set. The second argument's a function. In this case, we're using to upper. So Now, every single column name has uppercase. So we said or column names. So there are some functions in R that, in base R, that are still very useful. So let's say you want to just, for some odd reason, grab all the column names. Column names, cars. That'll give you a vector back of the column names. Okay? Now, if we go to the help of column names, there are two row names and column names. We're not going to do anything with row names throughout the entire course, so I'm not going to talk about that. So there are two different functions here. Column names, X. Data set. X is data set in this case. So it says column names. So do you want to extract them out? You want to extract out the column names. Alternatively, this is a different function where you can actually set the column names to a specific vector. So let's say you had a data set and you're like, oh, I read it in and all these column names, I have 1,000 column names and they're all confusing and they're not supposed to be like this, but I have like the list of 1,000 column names that I know are in the specific correct order, right? Which is you better be sure, right? Then you can actually set the column names of a data set to a vector, to like something like that. So if I said column names cars equals MPG, cylinder, displacement, right? I can do that. But here's some of the rub. One, if they're not in the right order, you're done. It's not going to work right. You've renamed a column to like something that's completely wrong. Two, I only put in 4. There's like 10, 11 variables. So what happened to cars? Made them all NA. You said, hey, you only gave me like 3 columns. All the rest of them, like, I don't know what I'm supposed to call them. You didn't tell me. So what I'm saying is column names is good for extracting the columns of a data set. Column names for reassignment is not the way we're going to teach it. Use the rename function. Use the rename all function. Things like that. But I will say there are some limitations. It's not super easy to jump to when you have like 400 variables or 1,000 variables, things like that. It can be a little bit harder. Yeah?
Can you just rename all to like compress your variable names, like their underscore or something you want to remove?
So the difference would be instead of to upper, you would pass in a function that substitutes spaces with undercases, or undercases to nothing.
And how does R handle if you're reading in a data set that has spaces in the column names?
You get to stay. You can tell it different things, but the read underscores, like read Excel and all that kind of stuff, they'll stay.
What if your backticks, maybe?
Yeah, well, we'll see what in some of the data sets we're going to have. So I'll show in this we'll see some data sets that have those things in there. So that is a good point though. So you can't have like special stuff in column names, or you can, but it handles it a little bit differently. So special stuff, spaces, dashes, dollar signs, pounds, things like that, right? Those things, parentheses, right? If you have all those in your column names, like R knows them as something completely different. So you have to do special things if you want to keep those column names the way they are. You have to just do some special things, which we'll show you in a minute, called backticks. Or what I do most of the time, every time I read in a data set with something like that, I rename the columns to something normal. And normal, I mean it can't start with a number, right? Column names can't start with a number. They can start with pretty much just alphabetical letters. They can have underscores. They can have periods, but they cannot have dashes. I mean, it's not that they can't have them. It's just then you have to do these special things. But they're not recommended. All right. You want to grab, and you'll see why in a second, why you can't use dollar sign. So you want to grab one column off a data set. Okay? One column. Only. And you want to return the vector. Right? So let's say you had 32 observations. You want to grab that 32 numbers. You can use the dollar sign. So data frame, dollar sign, column name. Okay? So For example, df $carb, it grabs the carb column. Just as a normal vector, doing whatever you want with it. This is going to be particularly useful when we talk about summarization or statistical operations like mean, standard deviation, that kind of stuff, because those assume you're going to pass in a vector. So we talked about rename, which is a dplyr command. Select. So select selects columns. Okay. Select says, hey, data set, first argument is data set, like everything else. Select the data set, I want to grab MPG. Okay? What this will give you is 32 rows and 1 column, but it's still a data set, still a data frame, still a Tibble. You can still use all your fun operations here. Here, it's a vector. You cannot use the verbs I'm going to tell you today, rename, all that kind of stuff on vectors. They only work on data sets. Lastly, there is a dplyr way of grabbing a specific column. So like this, you can use the $sign. So I will say, even though I use the tidyverse for a lot of my stuff, I still use the $sign for a lot of my work. Pull extracts 1 column and turns it into a data frame. So again, turns it into a vector. My apologies. So let's say you wanted to grab miles per gallon. You could select only that column and just say pull. You could have also just say from the data set, MPG. What is indeed? Let's say carb. Carb. So pull in the tidyverse is like the $sign. So you say, I want to grab that and turn it into a vector. Pull will do that. So again, like select, like rename, right? First argument is always a data set. So yeah.
So what were the numbers between the brackets?
Numbers between.
See, like the 1 to 15 to 29.
Again, these are just like guideposts to tell you like what index that is. So this is the first observation. This one's the 15th observation. This one's the 29th observation. So if you are like looking at data, you're like, that one is super weird. You're like 15, 16, 17, 18, 19, 20. It's the 20th. So they're just signposts. Just show you where you are. Now select. Usually you're not just selecting one column. You can put in multiple columns, many columns of the data set you want, separated by columns. So before we just selected miles per gallon. Here we're selecting miles per gallon in cylinder. Right? Should be a pretty intuitive jump to 2 or more. Now there are a bunch of helpers. So I will bring up the help file for this. If you run this command, it should come up with a help file in your R. We'll talk about these little question marks a little bit later. But here are a few. One of, last col, ends with, contains, and matches. So those allow us to do things like I want to grab all the columns that start with X. Lowercase x, uppercase X, whatever. So make this a little bit smaller. So these tidy select helpers, for example, starts with, then you put in a character string, starts with an uppercase X, a lowercase x, whatever, ends with the number 1, ends with the number 5, or ends with, lowercase l, contains a literal string. So it's going to match things exactly. Matches, we're going to talk a little bit about regular expressions, but they're a little bit more high-level stuff. So like, let's say you wanted to match something where it's like, it has to start with the letter A, and then it has to have the letter B somewhere, and then it has to end with the letter Q, right? Regular expressions are a way for you to express that. Number range, one of, so you say, matches a variable in a character vector, so you give a character vector, it's like, so let's say you had 5 data sets, and in data set 1, the column you want is called x1, and in data set 2, it's called x3, and stuff like that. You can say, for each one of them, go through and grab if it's one of x1, x2, or x3, for example. Everything matches all variables. That is not going to be super useful, right, because you're just selecting everything. It's useful when we go to reorder the columns. So you say select miles per gallon, comma, everything. right? We'll show that in the notes, but pretty much that'll put miles per gallon as the first column, right? So you can reorder them. Last column, so select the last variable, and it says potentially with an offset. So you want to say like, oh, I want the second to last column or third to last column, things like that. All right, we're gonna move on to lab part 2, but before we do that, any questions? So select, we got rename, we got select. Okay, we've also talked a little bit about pull. You're gonna grab things and the dollar sign if you want to extract just one single column. Pull and dollar sign, extracting a single column. Now it's a vector. So we changed it. Okay.
Can we extract the dollar sign like multiple?
Nope. Dollar sign's only for one. One shot only. One column only. So if you were to want to grab multiple columns, you would use select.
And what's the difference between the pull and the select?
So pull, like the dollar sign, grabs only one thing. Can only grab one vector, or sorry, one column. But what it does is it not only just selects one of them, it turns it into the vector. So before select, you had a whole data set, right? Miles per gallon, you have 32 rows in one column. Next, it's just a vector with 32 elements. And the reason that's important is because all the verbs we're talking about, you have to take in a data set every single time. You cannot put in vectors into this stuff, into rename, into select, that kind of stuff. It has to be a data set with rows and columns. But some functions in R, like the mean function, says you need to pass me a vector. Okay? So if you want to just do like the mean in one column, there are ways to do that in the tidy way. But sometimes you're just like, I just want to do the mean or something like that, or some function where it's like, I need a vector. So you either use dollar sign or you use pull. Okay. All right, we're gonna just skip over number 6. I skipped over the slides. Pretty much the long and short of it is, if you have a data set that happens to have row names and you want to turn those row names into a column, there is a function that does that. But again, most of the stuff you're doing now, when you read data straight in, they don't read in row names or anything like that. So it's just, it's not going to be relevant to your day-to-day stuff. But when I showed you the MT cars data set, that happens to be one of the data sets where it doesn't actually have a column of which car it is. They're actually assigned to the row names, which is really, really bad practice. So just skip number 6. Can you take 6 out? Yeah. And take the row names, the columns thing.
I don't find it.
That assumes they use the JG version.
No.
Then the cars are not.
No, cars is done from above. Cars was copied above.
But the rows are car names. So you use that.
No. That's fine. I would say floater, just because questions come. But that sometimes like it happens. So just want to show you so if you have that.
So, right now, right, via that, we have no things. I'll give you a little preview of what we're going to talk about.
So we know what outcome was obviously was already last.
Yep. Okay. We're going to talk about this a little bit. It's called like, yeah, we were talking about it. Okay. So the thing is, so this pipe, that's specifically the pipe we have on our plans. But that will hopefully alleviate some of those.
Yeah.
What was it?
I'm not sure.
So we're subsetting, right? So again, so we're gonna select columns. So it's gonna be select. Okay. First argument.
Okay, so
So, and then we're gonna use the function and
it's awesome.
and then parentheses. Perfect. So we're gonna use so say anything that ends with P. Yeah, try that. So try that. So scroll up. So this HP, two columns, right? So now all we gotta do is follow that so we know what P was. So we can assign that to okay. So again, we could have said DP and HP and that we use the same thing instead of this end with thing, but it's in practice like what if you want to just get all the things like all so you could have started. So let's put something else in there. Let's put a little let's say drop DRAT.
Oh, yeah.
No, before that. Let's say DRAT. So that means like so combine it so this are right. So
Yeah, so
combine those little action
so
items.
you can really put out.
So you have it, so it's just combine this. So I can list it and then I can also use something like that. But
Like also might be a flat in front of those what you say contains. So you don't even need actually for this anything in this function. You can just delete the contains. First parentheses. And then the last one. Yeah, it's like but you don't need to use quotes in select. Like you say annotate, you don't need to quotes. I believe it was still select before you be able to get cards. Yeah. So basically want this thing.
So time like this is like it's let's go back.
That was the when you run it, it just won't pop up. Oh, it's just good. Oh no, this is good. So you just have keywords here. Yeah. And then took that as a lab, but I left it in the lecture notes in case people else run into this.
Push it to the end.
Push it.
No, push. Put the slides to the end.
Should I have done this like that?
No. So you can't mix and match. So dollar sign is a base thing,
Oh, okay.
right? And that's the whole point of using this function. You don't have to use the dollar sign because when you say select this data set, it knows that WT, QSEC, HB is all coming to it. It takes the sense.
Yeah.
Like, I didn't like, you want to still have it. select. So you want to subset it as oh,
You never electronic PDF.
I never what?
Never change that
It should be in the big.
PDF.
Okay, I'll do it.
That's why I got the HTML.
Yeah, that's fine.
you want to overall make file that runs all the subject files?
Yeah.
Okay.
It's knowing that electronic PDF doesn't work, that would be useful.
It's not that great. It's okay.
It's not, we're just going to HTML to PDF.
So I want to make them identical.
Should be open. Should be some, I'll throw cross-platform one for not for this class.
Yeah.
I was trying to fix all the backticks in the last lecture. So you can probably skip the backslash.
The tab, I fixed that.
You did? Oh, cool. Okay.
I try open that left
I
tab.
didn't check. I just did.
Question just back to the poll and select. Do you have to use the select command inside?
No. So you can either you can pull one, you can either give pull a data set in one column, you'll just notice which one to pull, or you say pull the data set and then you give the column one pull. So it you can do it one way or the other. If you're like, oh, I know I only have one column, you should say pull and knows what to do. But more explicitly, you just say pull this column. All right, I'm gonna go through part one, or just number one, or number 7, I guess. So subset the columns from cars that ends in P. So again, you could use the cars from above. I'm gonna use JHU cars, which is exactly the same copy of that data set, except for one small difference. It actually has the car as a column. So if you look at empty cars and you look at cars, I actually have a column that's called car here, whereas in the other one I don't. So here I'm going to say select cars ends with P. Okay. This is going to give me 2 columns, disp and HP for horsepower. But again, if I look at cars, nothing's changed. Now I want to assign this to a thing called pvars. Now, ends with is one of these helpers. You can mix and match, so you can use this with every kind of other select. So let's say I want car, let's say I want miles per gallon and anything that ends with P. So I don't just have to use one of these. It's not like I have to do either or. You can do them in combination. Miles per gallon and ends with P. Select, also the order matters in the sense like if you say ends with P and then miles per gallon, something like that. And I look at pvars. Difference between these two is miles per gallon was first because I said select that one first. This one I said get anything that ends with P. It's going to preserve the original order in the original data set. This was first and then HP. It's not going to like reorder them by alphabetically or anything like that. And then it grabs miles per gallon. Okay? So select the order can shuffle around your columns. So you can so again, ends with is a really important one. Contains and these other helpers are super powerful. If you use stata, it's like using the star for certain things. SAS, I forget what the equivalent is. Okay. Now we have a copy of this data set. It's only got the pvars columns. Let me take this out. Okay? Does that make sense? So again, I had this question a few times.
So I can use pull, pvars, and I can say HP. I don't need to select in any way, but if I just say pull pvars, it's going to grab, it grabs the last one by default, but I generally would not do just pull with a data set. I would tell it which column I want you to pull, or I would select only one variable and then pull that. So pull, you don't need the select function, but if it only has, I guess it pulls the very last one by default, which I don't love. I would rather be more explicit about that. Now, the other thing, so we introduced the dollar sign because you're still going to see that pervasive, and you're still going to use that in a lot of respects. But you don't mix and match the dollar sign with this type of these dplyr functions because you don't need to. Because the dollar sign is important because you say data set dollar sign column, right? The important part about that is you say, oh, this is the data set you're using. Now, but all these dplyr functions, all these verbs, the first argument is always the data set. So whenever you do these things like miles per gallon and stuff like that, it knows you're referencing that data set. Okay? So let's create a subset of the data that only contains the columns WT, QSEC, and HP, and assign this object to cars sub. What are the dimensions of this data set? So let's say cars sub equals. We're going to select cars. We're going to say WT, QSEC, and HP. All right. Pretty straightforward select command. And then I say dim cars sub. All right, so it's 32 rows and 3 columns. I could now also say n row, cars sub, and col, cars sub. Do anything with that.
Why wouldn't we use
Contains?
Yeah.
It could be that as well. So that's just a different way of doing it. So contains is trying to look for strings. It does work, but I want to give you an example of why. So I'm going to make a new column. Okay. Cars. I haven't showed you how to make a new column yet, so this is going to be a little bit different. So it's going to be mutate cars. HP2 is HP squared. Okay. So now I have a column HP. Now I have a column HP squared. So let's say I say contains HP or contains WT contains QSEC. So HP2 is going to be in there because HP2 contains HP. But if you wanted to, so two very important things. One, you can explicitly just say which ones you want. Two, these functions, almost all the helpers, pass in an actual character string. So you can't just say contains HP, right? It's not the same thing. R sees that as something different. So when you use these helpers, almost always you're going to put things in quotes, or if you're passing in a vector, you have to use the collect argument. So if you said a whole bunch of things like contain, I don't know if you can do this with contains, but for example, if you needed to pass a vector, you would pass it like that, right?
If you would have done contains HP squared for HP2 instead of HP, would it have brought?
It would not, because HP does not contain HP2. So sometimes that's what you want, sometimes that's not what you want, but you can be explicit. And the nice thing is you don't have to put quotes or anything around it. And then later, in about 5 minutes, I'll show you this thing called the pipe, which if you use that with certain functions, like dplyr functions, when you use this pipe, it looks confusing, I'll tell you about it in a minute, but the nice thing about it is if you do use this, you're piping this data set in here, then you hit tab inside of the function, it'll give you a whole bunch of stuff, but if you go to so I'm at the top, if you hit up, you go to the bottom, here are all the columns of that data set. So I don't have to remember what was it called. Was it called carb? Was it called carb 2? Was it capital C? All that kind of stuff. So this does some nice tab completion to show you what columns are in that data set. We're not getting to that yet.
So I choose subset instead of something.
Subset's a completely different command. The command subset, that is a completely different command. So it exists. We'll talk about how to subset rows. It's the filter function that we're going to be using. I would suggest for right now not using the subset command. So now we're going to do the same thing like we did before. This is just reiterating. We want to rename all the cars sub to upper. So again, now we're putting in the cars sub data set. We don't want anything to happen to cars. We just want to do uppercase to this data set, so we reassign it. Cars stays the same. Cars sub now has all uppercase columns. Okay? That last one's just a reiteration of the last point. Any questions before we move on? Okay. Filter. We have select for columns. We have rename for renaming columns. We have filter for filtering rows, for subsetting data based on some criteria of the data usually. So in this case, filter, like every other verb I told you so far, the first argument is the data set. Then you give it some sort of logical expression, right? It should come up true or false for certain things. This here is saying, is miles per gallon is greater than 20. The next operator is called the pipe, which stands for or miles per gallon is less than 14. So it's greater than 20 or it's less than 14, and we see all the miles per gallon here are either greater than 20 or less than 14. Greater than 20, less than 14. Nothing between 14 and 20 inclusive is in there. So again, filter, data frame, something logical, right? That logical expression can be very complex, right? The way you can have multiple logical conditions, the ampersand is for and, the pipe is for or. The pipe should be above your enter button, I believe, on a Mac. If you hold shift down, ampersand should be number, 7. Yeah. So, filter. Here's a big difference. When you separate things by commas in filter, by default, or pretty much always, it assumes you want to and those together. You want to do those intersections. So if I say filter data frame miles per gallon is greater than 20 and the cylinder is equal to 4, we see only 4s here, we see only miles per gallon that are jointly greater than 20 and the cylinders are equal to 4. We could have also done that this way. Let me see one more. Sorry, I went forward. So if I put a comma, here, it's the exact same thing. Exact same expression. So by default, when you put comma between expressions, if you have multiple expressions you want to do, filter is going to and them together. This and this and this and this. It's not always what you want. So just like any the operations for addition, subtraction, all that kind of stuff, you can group terms together with parentheses. So I want this or this and this, right? You put parentheses around the things you want to group together. So if we wanted, for example, I wanted miles per gallon or the cylinder was equal to 2, miles per gallon greater than 20, or the cylinder is equal to 4, I have to use the pipe explicitly. I tend to not use the comma in filter at all. I tend to just give it some logical expression, even if it's very complex, and I just do and. But if you want, by default, you want to say miles per gallon, comma, miles per gallon greater than 20, comma, cylinder equal to 4, it'll give the exact same answer as this one. So, selects columns, allows you to move them around, reorder them, all that fun stuff. Filter, subsets the rows. Alright, let's move on to the lab. Andrew, there were 40 more slides in this lecture. lecture, I think. So we got about 2 questions for this. We're going to take about 5 to 7 minutes.
Yeah.
That's changed. Ah. Okay. So let's look at your card dates. Just click that one. Click the first column. Oh. So it's capital. So
Because I did G
rename.
all cap.
Yep. So let's try it again with the capital.
Because of this command.
Well,
Well, actually,
that was parse. Again, it was because of the data set we before. So again, we need punching, and we're going to make sure you have the right column name. That's not the main. Probably the main issue, but again.
so if they were to piping the
Yep.
this after the
And then filter. Yep. Our data set and then filter.
Yeah, that was
oh, okay.
Exactly. No, no, the TS. Yeah, I just like saw it where.
So
Yeah.
when I use the filter command, it will actually show on the console all the. It won't like cut. It will not only show a few, right? Like a tip. It will show everything.
If
So
it's
the
a
answer.
Yeah.
So the answer to how many is 14.
Yeah. So sign that to something. Let's call it exercise. And then use either nrow or dim or something like that to make sure.
Okay. So we're going to subset on the rows of cars that get more than 20 miles per gallon. We're using lowercase MPG. So if, again, for some reason you had some uppercase MPG in your data set, probably just grab the cars equals JHU cars just to start out maybe. So let's say cars, let's say filter. We want to filter the cars where MPG is greater than 20. Right, so we see there's 14 rows here, but let's say something like, we want to say X equals this. We can say n row X to see how many that is the case. Andrew will show you a bit later. So sometimes it is worthwhile, in some respects, to do the $sign. I would probably do something like MPG greater than 20, where I get trues and falses and then just sum it up. Sometimes, so when we show sum, that's some way I would still recommend doing it. We could use pull, things like that where you create a new variable, but right now, just assigning that to an object and then getting the number of rows, or just seeing here that it's 14 rows, should be fine for now. Subset the rows that get less than 16 miles per gallon of fuel efficiency and have more than 100 horsepower. How many are there? So, who's got a number for me? How many are there? I don't know.
10 and 11.
10 and 11. Should be one number. Right? So we should have cars. So it should, MPG is greater than, less than 16, and horsepower is greater than 100. So we should have 10 cars that fit that criteria. Okay? So if I asked or, right, again, there's 23 cars that either have less than 60 miles per gallon or over 100 horsepower. And again, if we put the comma here, we would see that we got the same exact answer that if we put the ampersand. And what I was saying before about grouping things together, like if you want to say, I want to know who's got less than 16 miles per gallon and it's greater than 100, or cylinders equals 5, I think it's a 6-cylinder, right? You can do something like this, which will give you the records back that if you have low MPG and a high horsepower, or you have 6-cylinder engines. Stuff like that. So that's how you can make a complex if statement based on your kind of data set. Okay? So, a lot of times what you're going to do is combine these two things. Remember, the verbs I showed you today, all of them take in the data set as the first argument, and they return the data set. So what you can do is, let's say we filter the data set where miles per gallon is greater than 20 and cylinders equals 4. This whole command right here returns a data set, right? So then we can put that as the new data set we're putting in select, and then we're taking in, we just want the cylinders and the horsepowers. So these are the cylinder and horsepower for miles per gallon greater than 20 and a 4-cylinder engine. So these are the horsepowers for those 4-cylinder cars.
So then the data set goes into the second function, not as the first after select, like instead of saying select GF and then filter.
So the way R works is kind of like a middle out type of evaluation. So it evaluates the first function, right? So it says, give this back. This whole thing creates like essentially a temporary data set object that then gets passed into select. But you're right, you wouldn't say select DF and then filter, stuff like that. Well, I'll show you in a minute how piping works, and that's essentially the central idea is that you keep passing it down over and over and over again. So an R, common way to perform multiple operations is to wrap functions around each other in a nested way as above. Right? This is not commonly seen in a lot of code. So another way we could have done it, right? Let's assign a new data set, df2, where we got the output from filter. This is essentially what's going on in the background, but there is no df2. So we created a new data set, df2, and then we put that df2 into this data set and got the output and just selected those columns. Same idea. Now, one of the issues with this is like, why do you want to reassign it over and over and over again? So this is the pipe. So it's a percent greater than sign, percent sign. It's Command or Control Shift M on your machine. So everybody go to RStudio right now. Click Command Shift M. So you should be getting this. So like if you hold it down, right? Everybody getting that? Or Control Shift M, I think for Windows. That's the pipe. The reason I took the time out to make everybody go there and learn that shortcut command because I find a lot of students feel like this is more intuitive and they start to actually use it and like they're like, well, I don't like it's like they put a space in the percent and all that kind of stuff. Just use the keyboard shortcut. Life will be easier. Control Shift M. So it's M because this this pipe was from a package called the Magritte R. So if you know the painting, this is not a picture of a pipe. So it's this whole play on pipes and stuff like that because it was made by some computer scientist guy who's like, this is a pipe, but it's not a pipe. Anyway, that's why it's M. Okay, Magritte. Okay, now, so that same operation we did before can be viewed as this. So the pipe operator, you can think of, you actually pipe an object into the next thing, or it's also conceptually thought of and then, right? So you take the data set and then you filter it based on this criteria. And then you select these columns. So again, what the pipe does, the very, very core, all it does is it takes the argument on the left and puts it as the first argument on the right. And that's why every single command, the first argument is the data set. So it makes it super easy to pipe things together. So this operation, we didn't have to do reassignment. We didn't have to do anything like that. This doesn't all have to be on the same line, but it's just simpler to see what happens. So readable, so this should be a lot more readable, right? You take a data set, then you filter these rows based on this criteria, then you select these columns. Okay? And I'll show you an added benefit that if you use the pipe, you can use tab completion for the column names. So before, if you said select, data frame, you're like, what is it called? Is it HP? Is it horsepower? I don't remember. If you use the pipe, which is another reason you should use it, you hit tab inside of there and it'll list all the columns out for you. So, to be clear, when I said it doesn't have to be when it doesn't have to be on one line, it can be like this. I will say, though, the pipe should be almost generally the last thing on the line if you're going to continue on going. Right? So it should be data frame, pipe, filter, 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 pipe, and then the last thing. Okay? If you did this, this is a totally valid command to R. You're done. You wanted it to filter something. Done. So if you run this, it's like, what are you talking about? I got it done. I filtered it. I printed it out for you. Now you're just piping nothing into me. So when you do this, if you do it on multiple lines, the pipe should be, if you want to keep going and continue on, the pipe should be the last thing on that line. Okay? If you want it to be clean and readable. So again, this should be a lot more readable than necessarily, you know, that nested thing I showed before. And again, like I said, if you tab has the arguments for the function, but then it also has all the other columns of this data set for you to like access. So you don't have to remember what did you name this column, because again, not everybody has really nice column names like MPG and cylinder and all that kind of stuff. And that goes for rename, that goes for filter, that goes for select, and everything else we're talking about. So, adding and removing columns. $ is not just for grabbing a column, you can also reassign one out. Again, this is kind of a shorthand. It's useful for one shot. You create one column, right? Sometimes that's all you want to do. You want to do it kind of quick. So you say df new col equals df weight divided by 2.2. Bless you, right? So we create a new column. It's got weight divided by 2.2 kilograms, for example. But most of the time, in the dplyr way, the way you guys should probably will be doing this from here on out, mutate. Mutate is the function for creating columns. Okay? So we got selecting columns, we got filtering rows, we have renaming stuff, and we have mutate. So again, first argument, like everything else we just talked about, data set. So the new data set is now mutated. We took the old data set, we created this new column equals some old column or some manipulation divided by 2, or weight divided by 2.2 to give it in kilograms, for example. Okay? Mutate changes columns, adds columns.
We don't need to use parentheses when you're creating a new column, right?
Nope. As long as you make it not spaces and all that other stuff, yeah. Okay? So it's just new equals old, and again, you can create 10 different columns in this. You just put a comma and then it's like new column 2 equals this. New column 4 equals whatever. Okay? So you don't just have to do one at a time, you could do 5 or 10 or just one.
What's the difference between the dollar sign and the mutate?
So they're very, very, very different, right? So mutate takes in the data set, it's a function. The dollar sign, if that confuses you, don't use it. Pretty much, it allows for a one shot, you want to make one column.
So it adds one column.
Well, you're saying this new column is equal to something, right? Pretty much if you're creating new columns, probably stick with mutate for now. But again, I'm saying this exists in the wild. This is what people will recommend to you to do. Just understand that is the equivalent of mutate. Mutate is what you should be doing, probably going on forward if you're a new learner. But I will say the dollar sign is very, very pervasive. Like everybody who's grew up in our past, like 5 years ago, still uses it pretty frequently. So it's just an exposure thing for you to do, not necessarily for you to use to create your columns. Okay? So, creating conditional variables. So most times you don't just want to say like, hey, like I want to create a new column or weight divided by 2.2. There's a function called if-else. If-else takes a logical test, right? Something greater than 5 or less than 4, whatever. And when that's true, it replaces it with whatever is in the yes. So it's test, what you want to replace it with if it's true, what you want to replace it with if it's false. Okay? So here, for example, we want to mutate the data set. We want to take the displacement category. That's a new column we're creating. We want to set it equal to, if else, displacement's less than 200, it's low. And then what we can do, we could have said high otherwise, right? But let's say we don't want to just do high and low. We pass in, is it less than 200? We want to say it's low. And then for the false, right, so it's not less than 200, which means these values, these things, are greater than 200, right? So whatever came up false. Then we say, is displacement less than 400? It's going to be medium, and then otherwise call it high. So this is a complex if statement that pretty much says, if you are greater than 200, but less, or greater than 200 and less than or equal to 400, you're called medium. If you're greater than 400, you're called high. If you're lower than, less than or equal to 200, you're called low. Okay? Don't worry about. I'm just extracting that one column so we can see what comes out. It's low, medium, and high. Right? Could have done select here as well.
It doesn't need to put the data in if else because it's.
So the data is the first argument of mutate. After that, it knows you're grabbing columns from that data set. Excuse me? Sorry, I couldn't hear. If else?
Yeah. So that's basically the condition.
Yep.
And then you put the argument.
So what do you want to assign to this variable if that condition is true? In this case, if it's less than or equal to 200, we say low. So we could have said low, high, right, for example, and then be done with it. That would be it. So anything less than 200 is low, anything greater than or less than or equal to 200 is low, anything greater than 200 is high, right? So we could have done that, but instead this is the logical, this comes up true, then this is what happens when it's false. So when it's false, it actually goes into another statement.
Is it supposed to be more than 400 or less than 400?
Nope, it's saying, so less than 400, you say medium, this is the true. So when it's less than 200, this is true, but this is false, which means it's greater than 200 here. But when it's less than 400, that means it's greater than 200, less than or equal to 400. We call it medium. And then the alternative, the false here means it's not less than 200, it's not less than or equal to 400, which means it's greater than 400. Okay? That's one way to make a complex if statement. There is another function which might make it a little bit easier, but it is a little bit different syntax. So it's called case underscore when. Okay? So again, we're just mutating here, we're making new columns. Nothing's new about the mutate. Still making new columns. So we're making disp cat 2, and it's equal to case when. We're not using if else in this setting. We're saying, is displacement less than or equal to 200? And then this tilde operator, so above the left-hand side on your keyboard, says if it's less than 200, assign it to low. If it's greater than 200 and less than or equal to 400, assign it to medium. If it's greater than 400, assign it to high. Okay? It's a different way of doing conditionals. Again, whichever one kind of makes more sense to you, use it that way. I understand, I think this is a bit more explicit, but this tilde might be a little bit confusing starting out, but it's just saying, what do you want to assign it to in these cases? Now, we use displacement over and over and over again. You didn't have to, right? We could say, is displacement less than or equal to 200 and your age is 45 or something like that? It could have been any complex type of statement over here that returns a true or a false for each case. Okay? The more complex, though, that you do get into, just remember, you have to make sure you cover all your cases, right? So you're not just accidentally assigning someone to some of these categories where something's gone wrong, like, you accidentally, let's say the missing value for displacement was like 9,000 or something like that. They put that in your data set. Here, that's going to be assigned to a real value of high, right? So that's not what you necessarily want. So you'd have to do some data checking to make sure it is what you want. So again, this is not the way I would recommend to remove columns. But this is, in the base way, you would see someone's like, oh, remove a column. You assign it equal to this thing called null, all caps, right? That's the way it's done in base. But really, what we're going to show you how to do is if you want to remove a column, you still use select, you just use the minus operator, right? So subtract it away, right? Select, if you say, I want this column, this column, this column, this column, that's fine. But when you put this negative or parenthesis, or sorry, hyphen behind it, it's saying subtract that one away. So this is saying, give me this data set with all the columns except for new column. Okay? So subtracting removes columns in select. And this works for all those other helpers, right? So when we said, like, hey, I want all the variables that end with P, I would have said negative on that, like minus sign, and it would have gave me all the variables except the ones that end with P, because we would have subtracted them away. Okay? Similarly, if you say data frame minus one of, so it'll remove if it sees drat or new col, and it'll remove those columns if it sees it because of the negative sign. So not only do you use negative sign on the actual columns, you can use it with the helpers that we talked about to kind of flip the script and do it the opposite way. Remove them instead of just keep them. Okay? So sometimes, especially when you're making tables or reports and stuff like that, you want to order the columns. So here's a way you put new column in the very first column and everything else stays in order. So select, I'm going to select new column and then everything else. That's one of the reasons, that's one of the good uses for everything. So now new column is in the first. Let's go back really briefly. Before, the first column was car. Now the first column is new column and everything was shifted over one spot. Putting it at the end is a little bit weirder, I think. This is I don't know if there's a better way to do this, but this is the way I would move stuff to the back, where you remove the column, put everything in there, and then put the column back. Put the column at the end. So that's, again, most of the time this doesn't matter for a lot of the stuff I do. Like I'm doing models and stuff, but like sometimes if the order of it really matters, this is how you do
So when you're using the hyphen, it's like being erased from the database, right? It stays there. It just doesn't show on the table.
Nope, it's erased from the database.
Okay.
So again, hold on. So when we do, I'm going forward. So when I do this, right? Again, I didn't if I reassign this to DF, it's gone. But right now it's just printing out. Right? Again, none of these things do anything to the data unless you reassign it. Okay? But yeah, if I ran whoop, now I'm going the wrong way. All right, if I ran this and then look back at the DF and I never reassigned it, new col is still there. Okay? So again, these might be special use cases, and a lot of times you care about like selecting columns, stuff like that, not necessarily the order. But again, if you select, the order in which you give them will be the order in which they are returned. Okay? So we have select, we have filter, we have rename, now we have mutate. Next one is arrange. Arrange will order your data set, will sort the rows. Okay? Sort is not the function you want though. Arrange is the command. There is a function called sort, that's not what you want. It's arrange. So again, everything, data set first. So here, you're arranging the data set by miles per gallon, and if you see, it'll go in increasing order by default. Okay? Here, there's a function called DESC for descending. Okay? So you arrange your data set by decreasing miles per gallon. Okay? This works on numbers, characters, all that kind of stuff. Right? Doesn't matter. It'll sort it by alphanumerically, all that fun stuff. And you can do combinations, right? So I want to first sort by miles per gallon, and then I want to sort by decreasing horsepower. So for example, right here, these two records have the exact same miles per gallon, but these were sorted first, right, in this row, and then, because they're tied, this one was sorted first before that one because it's in decreasing descending horsepower. Okay? Does that make sense? Right? You want to, so many times applications in medicine, you have multiple observations per person. You want to sort it maybe by a patient identifier and then date or decreasing date or visit number, that kind of stuff. So you can get as complex or simple as you may need. Transmute's a little weird. Bless you. So it's kind of a combination of select and mutate at the same time. I tend to not use that. I tend to be more explicit with selecting and mutating together, but this is kind of like a shorthand function that you pass in a data set. You can create new columns and select columns at the same time. But I don't see the utility of this per se, but it does exist if you think this makes a lot of sense where you transmute something. Go for it.
Could we do the same things like typing?
Absolutely. So you'd say data frame, pipe, mutate this, and then you would probably select miles per gallon, horsepower, and new col. Just to make sure new col was in there. Or new col too, yeah. Does that make sense? So, but the order of operations does matter, right? Because if I selected the data, right? If I selected horsepower and miles per gallon, and then I go to mutate this new column, weight is no longer there, right? So if you select stuff out, you better make sure you're keeping the stuff you need to compute on, right? Or compute on it first and then select everything you need. Okay. All right. So everything I talked about before, mutate, rename all that kind of stuff, all that can be piped, right? And the piping operation can be strung together into multiple, where you just take the data frame once, pipe, and then mutate, and then arrange, and then select, and then whatever. And then you can reassign all that out to the new output. So you'd say like data frame equals, or df equals df, pipe, whatever you want it to do. Okay? All right. We're going to move on to the lab. I'm trying to think. Yeah. How many things are in this lab? Nothing. 1, 2, 3. 10 minutes. I'll go over them very briefly. Actually, no. We'll skip them.
I think these 50 years past, that's why.
Yeah, I think we should. Okay. So lab part 4 of subsetting data, and then we'll switch over. So probably 10:55. Just a quick question: who else is taking another institute class in like the afternoon? Oh my gosh. Okay.
How many is the SCADA class? So why do we look at? So I'm data science. Yeah.
So you need to be bilingual at least daily. Yeah. In programming, so. But whatever you're learning there, I will say, like, don't hesitate to ask or send an email saying, like, I learned this in SCADA. I don't know how to do it in R. You can do that.
I feel like a lot of times when I try to set
Don't need that good. You put dollars on loans.
oh yeah, no, I think something got really nice with it.
But it should be, you mean, you want to do like tidy evaluation? Or like,
You know, like range by setting like most columns. And you have this tiny amount of columns set there. So it's going to do like different column instances. I don't think about it very
yeah.
nicely. Okay, so you
So,
take the card,
you're taking 8 cylinder cars, and then you only switch.
so if you want to have a connection that's next to if you want to reassign that means it's that means take card 7.
I mean, yeah,
So
that's fine.
You don't necessarily, but it's not a bad practice.
You buy first, you want to select.
So before you just don't have to wear those.
It's like right now you're saying, it's like, you two things happen.
That is a capitalist.
So how to select.
So this what is this going to do? They're just going to do.
So,
Well, this one is
Okay.
So this one will be creating new one.
okay.
I don't know.
So the
But there's not the, you don't want the individuals. So you can use the HP because they're not there for this.
Yeah. Yeah.
This is selecting the HP column. So all the other 2 rows.
And you can do
So you filter.
So you don't need to be a
Oh, I see. So now I have the three variables and the 2
Yeah,
variables.
you need another command to say subset this to just the HP.
It's called
I see. Right.
No.
Oh, you don't need to.
What you mean?
Yeah.
It used to be saved, but you basically see this like every time.
So I have to also add a pipe.
Yeah, so you're basically like streaming cars to that to the 32 by 3 data set, and then piping it again to the filter data set.
Oh, I see. So I started with cars,
Yeah.
and then with these, we do these, and then on this one, do this.
Yep.
I see.
Let's fix it out.
So now what?
Sorry, cylinders. So, sill, not. Oh. Oh, I see. So it's yep. Yeah, so sorry. Yeah, I tried. That's right. Oh, same as double.
Yeah,
Okay, perfect. Okay.
Thank you.
Yeah, so much.
Yes, so actually it's a little weird. So equals just equals. And then the one
Yeah, are they in there?
Subset rows. Like a slide. 24.
The different operators?
I
Like
I
a
don't know
slide of it. We have a slide of different operators.
yeah, so if you want to play with them, what you intend is so type is basically going to equate it so you want to
Yeah, look for it if you can.
oh, if you want to do the yeah, you can do that.
Is it manipulating data? Manipulating.
It might be a game.
Oh, so you can type it. Yeah, so if you oh no, actually.
Do you see it?
I'm just gonna add a slide.
You could do it all. Yes, if you type and then you don't want
Okay, let's go over the lab. go through a couple of these really quickly maybe. So let's create a subset from the cars data that only contains the columns WT, QSEC, and HP for only the cars with 8 cylinders and reassign this object to cars sub. What are the dimensions of this data set? So there are a few ways we can do this. Let's do some reassignment, for example. So I'm just going to say cars equals JHU cars just to reset to make sure I have the data set the way I need it to be. So I want to, let's say, filter filter cars sub, filter cars, the data set first, sil equals 8. So equals, by the way, explicitly, is the equal to operator. Okay? Cylinders is equal to 8. So this will run, and we'll get a data set. Now, if I do this, you'll get something weird. It says sil equals 8, must not be named. Do you mean equals? Right? So it tries to help you out. So we will talk about in data cleaning a little bit. This is the not equal to 8. Right? So this is the exclamation point equals. But for here, in this instance, we want cylinders is equal to 8. And then we can say cars sub equals select cars sub weight, QSEC, and HP. So that is a totally sufficient solution to the question at hand. Now, two things. What if I do it the other way? It says still not found. So first command, we dropped everything else but these 3 columns. Then we tried to filter on it. That column doesn't exist anymore. So the order matters here. So this reassignment over and over again might not be the cleanest way we can do it. So we're going to say cars, and then we're going to pipe it in to the filter command. Now again, because I'm using the pipe, I can use tab. I can say, oh, I want to use cylinder equals 8. And then I can select, and then I can hit tab, and I know I want WT, QSEC, and I hit tab, and it can complete it for me, and HP. And that'll give me what I want. So there's 2 different ways we did it. This is with the pipe. We piped it into filter first, then select. Again, if we switch the order here, that still is going to break. Because we only grab these 3 columns. It returns a data set with only 3 columns. Then if we try to filter on something that's not there, it's going to give us an error. Okay? Just to show you, if you don't believe me, cylinder not found, same error. Yes?
Suppose if we don't, if we just select it with 8, then we don't even need to filter it. Like,
So you can't, so how do you, so select will only grab the columns. It won't filter the rows. So dim car sub, it's going to be 14 rows. There's 14 cars with 8-cylinder engines. So maybe I don't understand your question.
I mean, like if we use select first, like how I messed it up here.
So if you select first, you'd have to put cylinders in there.
Is there any way we can put like cylinders equal to 8 there?
Nope, they're 2 separate commands. You have to do them separately. Yeah. So it's kind of one command does one thing really well. And then combining them together can be very powerful, but it doesn't try to do more than just one thing kind of at a time. Okay? Does this make sense? All right. So let's reorder the rows of car sub by weight in increasing order using the arrange command. So we can say arrange car sub, and then increasing order by weight, that's the default. And I can do that. We see weight has been ordered. So we didn't reassign it yet. So if we wanted it to stick, we could say cars. We'd have to reassign it. So we could have done this. Or using piping, now we say arrange. Again, we get access to all the variable names. And we could have done it either way. They both are totally valid. I tend to do stuff like this when I'm only doing one operation. But most of the time, I use pipes anyway, even if I'm doing just one thing, because the tab completion is very important to me. And also many times I'm not doing just one operation, I'm doing a range and then a mutate and all this kind of stuff. Okay, so we could have done again, like we see two of these weights are equal, we could have then done by descending qsec. And we see these two 15, so now qsec is explicitly ordered in descending after weight is ordered in increasing. So let's create a new variable called W2, which is weight 2, which is equal to weight squared using mutate, use piping. So now we got cars sub. We're going to pipe it. Let's say mutate. The new one, what is the new variable name? WT2, right? So again, new equals some sort of manipulation of the data. So I'm going to say WT squared. We want it to stick, so we reassign it. Now we look at cars sub. We have a WT2 column that is now an additional column. Let's say, but I could have done WT3 equals weight cubed. HP equals square root HP. So we haven't talked about square root, but this is the square root function. Now, note this. I reassigned HP. I overwrote what was previously there. So the HP column was rewritten, just like every other thing we talked about, the data set and all that kind of stuff. So if I look at the HPs before, it was like 264, 150. If I look at cars sub now, HP is like 16, 12, all that kind of stuff. It allowed me to overwrite that column. Didn't yell at me. It's totally fine. Okay? I could have done something where like HP equals 4. Now HP is just 4. Yeah. So equal is a logical test. Is something equal to that? It'll come up true or false, right? That's what equal is for. Equals is for assignment. In this case, we are assigning a new column equal to some expression. Okay? When we put in functions, we say this argument is equal to this.
For the W2, for the WT2 equal.
So we're assigning a new variable in the data set is equal to this expression. Okay? So mutate, you can use, so over 15. Let's see. So you could have, none of these are really easy for like an equals, but you could have done like, and horsepower is equal to 10 or something like that. So this is okay, but this is still new variable, single equal sign because you're assigning it to a new thing, equal to some expression. Here I'm saying weight has to be greater than 15 and horsepower has to be equal to 10. That's on the right-hand side. This is logical. Saying, is that equal to 10? This is saying I'm assigning this, or creating this new variable, or manipulating this new variable, or mutating this new variable. Hence the name. Okay? So equals is specifically saying it is a test. You can think of it as an if statement. Is this thing equal to that? Equals, on the other hand, is assigning things, either in a function as an argument name, or a mutate to a new variable, or yeah. Okay, so all the standard operators you can think of, like greater than or equal to sign, works. Oh, okay. For the next lecture?
No, I put it back in these slides.
Okay. Which slide number?
What are the not equal? What are the and or higher up?
Why would you put it there? What slide?
There. Oh.
Anyway, all the operators you can normally think of, so greater than or equal to, less than or equal to, not equal to. Remember, equals is a little bit different. Ands and ors, and we'll talk about other things for missingness and missing data in the next lecture. All right. So the reason we took so long in this lecture is because with these tools, maybe additional reshaping, you can do like the majority of your data cleaning operations, data manipulation operations you need to do, right? You want a subset on like, I want to get a data set where it's only, some inclusion criteria of like this race and this sex plus this age criteria. You can do that with filtering, and then you want to grab only the columns if you read in 4,000 columns, you only want the ones you want. Right, that allows you to effectively reduce the data set to whatever inclusion you want versus whatever columns you want. And then once we teach you about like testing and some modeling and then plotting, like that, combined with these is some really, really powerful tools. But that's what you do for most data analysis. Any questions before we move on? All right. So these slides.